Hello everyone. Welcome to video lectures on probability and random variable. I am Professor Mayur Gohil. In this video, we shall be seeing details regarding probability density function. Now, for probability density function, first important thing is that we must have the random variable to be continuous. Okay, so let x be a continuous random variable if y is equals to fx is a continuous function such that number 1, the function f of x is integrable. Second, the function f of x is non-negative. Okay, and the integration of a to b the integration of a to b f of x dx is 1 if a is less than equal to x less than equal to b. And the third thing is integration of alpha to beta f of x dx is equal to probability of alpha less than or equal to capital X less than equal to beta, where alpha, I would rather say it would be like this, where a is less than alpha less than beta less than b. When this is happening, okay, then fx is called the PDF of random variable x. It is denoted by f suffix capital X bracket x, or simply we write it as fx, f of x. This is also okay, but this is the above one with suffix x capital X is more specific when the random variable is also shown over there. This is the definition of probability density function. Now we see the properties of probability density function. Let us see the property. Let me write here properties of PDF. The first property that is there is fx should be greater equal to 0. It is one part of the definition that we had seen, but we now again mention it over here. Fx is greater equal to 0 for x lying between minus infinity to, okay, so this is what is there. Now this also means here there is one very important thing to be understood here, that the graph of fx will always lie in first and second quadrant. This is one important thing. The second property that is there is that the integration of the function from minus infinity to infinity is 1. Okay, so it means that the total area under the function should be giving the answer 1. And the third property here is this, that integration from a to b, if you want write the capital X over here, it's okay, not a problem, dx is now going to be represented by probability a less than capital X less than b. So this is what it is there. Now for the first time you will see that probability is going to be represented by integration, and it has now got a meaning. Probability is now associated to area under the curve. Okay, so that is what is very important here, that this associates probability with area under fx in interval a comma b. Okay, another important property there is there over here that I would like to mention here, it is the fourth and very important property. It says that probability that whatever we get, which is p of a less than equal to x less than equal to b, is same as probability a, whether you have a strict inequality on one side or the other, or you have the strict inequality, the answer of probability is not going to change. Okay, it remains same across all the cases, because probability, if defined in this manner, so probability with integration at a particular point is always zero. Okay, so that is what it means here. So we'll not go into great detail of mathematics, because later on concepts, further concepts also come, so I'll not go into great detail, but here these are the some important properties that will help us. Now let me take you to a very important definition of cumulative distribution function related to continuous random variable. So here the definition is this, we'll write here again. So let capital X be a continuous RV with PDF fx. Okay, then capital Fx is equals to, by definition it is this. Okay, this is the main formula, but when the variable is capital X is continuous random variable, the formula has slight change. Last time when we saw the variable is a discrete random variable, it is a less than type of cumulative distribution we draw, but here it is going to be integral minus infinity to x f of u du. This is what is it. Okay, this is very important. So now let us summarize this part carefully, because this will help us a lot. And now also comes another important thing along with this, is the two formulas that we see. So the first important formula is, that is for CDF or cumulative distribution function, the definition is f x is equals to p capital X less than x. This is the main definition, this is the only formula rather. But this formula splits up into two formulas. The first formula is summation p of x equal to x, where capital X is less than or x. Okay, that is the formula that we have, and this is when we are having, when x is discrete random variable. Another one formula is minus infinity to x f of u du, when capital X is a continuous random variable. This is the formula that we have. So this is how it works, and this is how the whole thing goes about. Over here, there is one condition in this definition, that is, it should be minus infinity x less than infinity. That's how it is. But then people don't worry about it, but that's what technically it is there. Now, see, what is very important to know, cumulative distribution function, we always use capital F, okay? And sometimes it is used loosely, the name is used distribution function, which is a kind of a, you know, a very non-standard way of talking. Please see what notation is used. If it is used capital F, understand it is a continuous, it is, please see the notation which is used. If it is capital F, then remember it is cumulative distribution function, and if it is small f, then it is probability density function. Okay, please be clear about it, small f and capital F, because this confusion, if it is there, then it will be carried all throughout. So make it very clear at this stage. Okay, now there are some important properties that are worth noting over here for CDF. Properties of CDF. The first property is that CDF is always increasing function. Okay, it is an always increasing function, rather it is monotonically increasing. Then we have one another property that relates to the probability density function and the uh, cumulative distribution function, that says that if we do the derivative dy dx of capital F of x, okay, we will get the PDF. Okay, so this is the relationship between the CDF and the PDF of that random variable x. This is very important property according to me. Second and the third one, which is very much always helpful in advanced calculations, that P of A less than X less than B is equivalent to F of B minus F of A. So generally people write this like this, FB minus F of A. This is there. Okay, so that is what it is there, and we always have this very simple thing, that our answer for F of x is always between 0 and 1. This is what is there regarding cumulative distribution function. It's a quick recap I'm taking you through. So this is probability density function definition, which is in short written as PDF. PDF is always for a continuous random variable. These are the properties of probability density function. Then next is cumulative distribution function, that is generally written as CDF. What I would like you to know is there is only one main definition, which is this. This is the only main definition of CDF, but it splits up into two formulas as per the type of the random variable. In each of the case, either of the definition that you take, properties of CDF remain the same. Okay, these are the four important properties. I am not going into the geometrical aspect right now. We will see it along with the example in the next video lecture. I hope you liked the whole part of PDF and CDF. Please hit like button, share it with your friends, those who find this topic useful. Till then, keep solving good amount of mathematics. Please do hit like and share it with your friends. Thank you.